Hi everybody, this is Mrs. Ellsworth, and what we're going to be talking about today is the different levels in the atmospheric vertical profile. So let's get started. So when you look at your blue sheet that you had, okay, you have the troposphere, and you had to go and define that on the back side. Okay, and what did we come up with? Some ideas for what the troposphere. We know that it is the lowest level of our atmosphere. Anything more? It's where all the weather occurs. That's right. So make sure you know that the troposphere, of course, the bottom layer, and it's where all the weather occurs. It's where all of the molecules are really concentrated. If you think about the density of the air, all of those molecules and those atoms are being pushed down by gravity, and they are being pushed down, and so there are going to be a heavier concentration down here, meaning that there's more density and that there's more pressure down here. Okay, so then we have this. So the unique thing about the troposphere, though, is that it gets colder as you get higher. Okay, and then we've got this area here where it stays at the same temperature for a little while. Okay, now I'm sure that you were thinking as you were looking at that activity sheet, I'm sure you were thinking like, wow, the temperature is getting hotter in the stratosphere, and why is that? And so we'll talk about that too, on why that is occurring. But there's also a layer in here called the ozone. Okay, and that has to do with that temperature increasing. Okay, then we go up to the third one. Oh, wait a minute. Do you know that this is where all the commercial airplanes fly? Is because that's above the weather. Kind of makes sense because you're not going to have turbulence. It'll be in the stratosphere here. It's not as high as the ozone layer, I don't think. But it should probably be in this tropopause area here because it's stable. Very stable. So stable that the temperature is not changing. Okay, then as you increase altitude again, you're going higher and higher into the atmosphere. Then you hit the end of the stratosphere. And this right here is the stratopause. Okay, so the temperature is staying the same. And then as when you're in the mesosphere, now you've got the temperature going down again. And why is that? What is causing that to go down? And then at some point it levels out at a really cold temperature, and you're getting really close to the edge of the atmosphere. There's still another one after the thermosphere here. But I will tell you that there are, I think that the International Space Station is in the end of the thermosphere here. And so it is it's in orbit above here. Also, the thermosphere is sometimes called the ionosphere, because of all these ions from like solar flares. When they go in there, then they ignite and they so this right here, they are ions that are activated from a solar flare, and they are lit up because there's aurora borealis or else northern lights that is occurring at either one of the poles. And that's why it's sometimes called the ionosphere, because they're ions that came from that solar flare, and they are excited and they're lit up, and they are actually creating a lot of heat. There's not very many molecules up here. In fact, it's not very dense at all. There's so few, but they have the ability to have lots of energy because they've got lots of room to move. Because there's no other atoms and stuff nearby. It's so has such low pressure up here. But with the X-rays and the ultraviolet rays that are in here, it has the ability to gather a lot of heat. Now there is one more sphere above this called the exosphere. You might have seen that on that blue sheet when you were looking for that. And the exosphere is the outermost layer before you hit space. It's quite a long distance too. And it we don't have much information on that. Anyways, I don't have much information on that. So that's what you guys should have been kind of looking at yesterday. So we're going to discuss those ideas, okay, the different layers, the heat inside of each one of them. We just kind of talked about those trends, okay, the density and the pressure. So we briefly talked about that too, and we will again. We'll also talk about the distinct pattern and what causes that, okay, and I think that I got that. Yeah, what causes that distinct pattern? What drives the weather, what makes all this weather happen, and also what drives the heat that's in the different layers. And we'll talk about what parcels are in the atmosphere, and we'll also talk about the convection currents and how that moves more heat around. And then how do they take those temperatures? And you may have also seen that from when you did the activity of your blue sheet too, what radiosondes are with weather balloons. Okay, so let's dig a little bit deeper. Do you have any questions? Okay, so we discussed the different layers, okay, and we talked about the heat trends in each one. Now we need to talk about a little bit more about these layers. So in the stratus layer, there's also this ozone layer. Okay, and for those of you who are watching the video, I'm gonna go show this ozone video, but then I want you to go and find it yourself. I'll show you the title of it. 15 to 35. Okay, we just watched this Climate 101 about ocean depletion from National Geographic. And so go ahead and look at that because that is also testable information. Okay, so in the stratosphere, we've got this ozone layer. Okay, and that is really important for heating up this stratosphere. So we'll talk about that in just a moment also. The mesosphere is where you will see the falling stars, which we really know are meteorites, right? And so you see a meteor, I should say, flying across the sky. And so, so that's where those are located. And then also, like you saw before, the aurora borealis, or also northern lights, are located up in the thermosphere. Okay, so I just wanted to remind us about something that we probably learned with our blue sheet activity, and that that close to the ground is has the highest pressure, and then it's least as you go up. Same with density. Again, the gravity pulls down all those molecules, and so they'll be the most dense. Okay, now this pressure changes and it fluctuates a little bit with the weather. Okay, our world is spinning, and when you have something spinning, things go and get mixed up. And so that's why the pressure isn't static all throughout here, but it doesn't vary a whole lot when you think about the number of millibars that things are. Okay, going on to the next topic here. How does each layer get a distinctive heat pattern? So when you think of the sun going and warming up the earth, what type of heat transfer is that? It's radiation. So we get radiant energy from the sun, and it heats up the troposphere here, and it really hits the surfaces, and that's where it heats it up. Okay, radiant energy does the most by hitting a surface and heating that surface up. It excites those molecules. Those molecules got kinetic energy, and they produce heat. So when you think about it, well, you know that it's not only occurring at the surface. You can get some temperature inversions to cause these horrible storms like we had yesterday. And you can also, you know that the heat is still here in our atmosphere. Well, So the sun is the driver of all the heat and all the weather. The sun drives all that. That's probably a test question. So the sun drives all the heat and the weather in our atmosphere. But then it transfers that to other water molecules through conduction. And conduction heats up all these molecules that come in contact here. And also convection. We learned about convection, remember, with that lab with the red and the blue food coloring, and we got to move. And so different parcels, and we'll be talking about that, parcels of sky move because it's less dense and hotter. Okay, so then that's how the troposphere goes. And so it just gets less and less heat as you go higher and higher. We talked about that. But the ozone in the stratosphere, the ozone actually absorbs all that ultraviolet light from the sun, and then guess what? It heats it up. And so the ozone, so the UV light coming in here, and so the ozone heats it up, and so heat rises. And so that's what makes the stratosphere actually get warmer as you go up. That's important information there. Okay, in the mesosphere, it gets colder after the pause here. There really isn't much to heat it up. There isn't much for molecules. The molecules that get excited are a little bit up higher in the thermosphere. And the thermosphere, these molecules are very, very far apart. They get hit by X-rays and the solar flares, and that is what actually they think creates so much heat in the thermosphere. Okay, then on to any questions on this? Okay, then going on to our fifth subject, what drives the weather? What drives the heat? And what did I say it was? It's the sun that does that. Okay, and then of course talking about the different parcels in the weather to go and change it. Let me talk about parcels. Okay, so parcels are little pieces of our atmosphere. They have no determined size. They have no there's nothing that describes the size. A parcel of atmosphere is a chunk of atmosphere. Some people in the younger grades call them a balloon without the balloon of atmosphere. So it's a big piece of atmosphere. Okay, like if you're looking at this piece right here that's discussed here on NOAA, they'll talk about some parcels getting cool and then they go down. Well, they're talking about a chunk of atmosphere. Well, how else could I describe it besides a big piece of the atmosphere? That sounds so solid, but yet this is all gas. Okay, then other ones get really warm from the weather that's going on, and then they go up because they're less dense. And so they talk about those being parcels because that helps us understand how convection is happening in our atmosphere. Okay, then back to our slideshow here. So then parcels is how that we also heat up our atmosphere through convection. Heat rises, cold goes downwards. And so then that helps drive and get that sun to mix up what's the weather that is occurring in our atmosphere. Because of course, you know, our world is turning. So nothing stays really static except for in these pause situations, the mesopause, stratopause. Okay, then looking on here, the radiospheres. This is pretty cool. So we're going to look at a small video talking about how that we go and measure the temperatures throughout our atmosphere. We do it twice a day all over the United States. I'll come back to it. Okay, so we learned from that video that there are 92 sites in the United States out of 900 worldwide. Okay, and they do it 2 times a day. And I can't remember what else I was going to say. Anyway, so we're going to move on forward. Thank you. Thank you. And that's the end of our information.